Hello students, welcome back. We're done with the essentials, sections 1 and 2. Now let's go to section 3, and as I told you before, it's okay to skip sections 3 and 4 or any part of those. After all, everything here, every single topic here in lesson 1 is a review from prerequisite courses such as college algebra, STEM algebra, business algebra, algebra for teachers, whatever algebra that is. If you feel comfortable, you can skip. Sections 1 and 2, I still advise you to go to read those even if you know everything and feel bored because they were essential. But here I don't say the same thing. Alright, anyway, let's begin. Here are the definitions of increasing versus decreasing functions. As x increases, the function value f of x increases or strictly increases or decreases or strictly decreases. Remember, the left-hand side is all the same. As x1 is less than x2 strictly, that means x2 is strictly bigger. So as x increases, how about the y-coordinate? Y-coordinate also increases like this, but this is semi-inequality, so it's okay to stay the same for a while like this. Horizontal segment here. And you can have a jump, but jump upward, never downward. Here's another example. This is continuous, increasing like this, but it's okay to have some horizontal segment here and there because this is semi-inequality. Now that's not okay for strict increasing like this. You have to have something like this. Strictly increasing, y-coordinate just strictly increases like this, and you can have jump or maybe no jump. Either way, strictly increasing. See the difference? Horizontal segment is okay. Not okay here. Of course, these are called increasing too. Now, how about this? Decreasing, like this. Or you can have some horizontal segment as well. By the way, this one is strictly decreasing as well, you see. And more strictly decreasing. Same inequality, less than or equal versus strictly less. This one is more inclusive. Likewise, this one is more inclusive. So if you say increasing, decreasing, then they include strictly increasing and strictly decreasing as well. When you say an interval of increase or decrease, then you include all those increasing, decreasing, focusing upon this and that mostly. And those are the largest of its kind. What do you mean by that? What do you mean by the largest? Well, let's go back to this picture. It's okay to say that increasing in 3 to 4, or interval 2 to 4, or 2 to 2.5, or negative 1 to 1. But you're looking at only microscopically. The largest of its kind of increasing, that should be negative infinity to positive infinity. It increases all the way, including this horizontal line segment. And again here, negative infinity to positive infinity. Now, if you want interval of strict increase, strictly increasing only, then you have to say 2 to infinity, negative infinity to 2, and here from 1 to 2, stay constant. Now, one more remark. The interval of increase and decrease reside inside the domain. So you must read the x-coordinate. These are x intervals. Am I making sense? I hope I did. But let us solidify our understanding through an example problem here. Okay, it's not too difficult to see the increasing, decreasing behavior directly from the graph. So we're going to have decreasing like this. And then over here, another decrease. I hope everybody can see that. And then in the middle, we'll have increasing segment. So how do I say increasing and decrease? Say, for example, can you say this increases from what's this point? -3 to 3 comma -2, this point. To this point here, 3 comma 3. And this statement is correct. This graph increases from -3 comma 2 to 3 comma 3. Look at this green segment. The statement itself is correct, but that's not an interval of increase. The interval of increase resides in the domain, so you have to answer it in terms of x-coordinate alone. So you have to answer the x-coordinate alone, irrespective of y-coordinate. You have to answer like this: -3 comma 3, x-coordinate only. Does it make sense? That's the subtlety I told you about at the end of 3.1. The intervals of increase and intervals of decrease reside in the domain. So you have to answer it in terms of the x-coordinates, not coordinates x comma y. So this pair is an interval notation, not -3 comma 3, not a coordinate expression. This is an interval. Let's get out of this drawing mode and let's have better pictures. So here's how you can determine intervals of increase, decrease. Decreasing, increasing, and decreasing. And decreasing part highlighted in red, increasing part highlighted in green, and decreasing part again highlighted in red. So in this interval, red interval, decreasing in -∞ to -3 in the red region. Do you see that? And increasing from -3 to +3 in the green region, and then decreasing again from 3 to infinity, the right-hand side red region. And all these intervals, those reside in the domain, so they are all x-coordinate values. X-coordinate -∞ to -3, x is between -3 and +3, x is between 3 and +infinity, completely irrespective of y-coordinate values. Now, we talked about increasing, decreasing. Now let's talk about extreme points, local and abstract extrema. By the way, extremum is a singular word in Latin, so it could be maximum or minimum, and plural form is extrema. Same goes to maxima, minima. So here are the definitions, but if you read through, oh boy, it's going to be really difficult to understand. So let me take a graphical viewpoint. Let's see. Let's suppose we have a graph like that. Okay, all right. And here are local maximum, another local maximum. So around here is the maximum. Close nearby it is maximum. Make sense? And these are local minima. There's one, and there's one, there's another one. So around here, in an open interval around it, it's a minimum. So we have local minimum like this. So local minimum, this should have been red. So local maximum value is the y-coordinate, and having local maximum, that's the x-coordinate. And having local minimum, that's the x-coordinate, and local minimum value is the y-coordinate. That can be a little bit confusing, so we're going to focus upon x-coordinate only all the time. And we are not going to worry about y-coordinate unless the problem explicitly asks you to find out both x-coordinate and y-coordinate and give you a blank space like MyMathLab does. If you have coordinate and then blank, comma, blank, and then you have to fill out those blanks, then you know you have to find out both x-coordinate and y-coordinate. Otherwise, we'll stick to x-coordinate only. Let's see, among these, and this one is the biggest. So this one is absolute maximum. And then this one is the smallest. Absolute minimum. So there are many local maxima, local minima, but absolute maximum, absolute minimum, unless we have a tie in very exceptional circumstance, we're going to have just one. And also, if you look at the y-coordinate values, then you have to have only one. Now, a little bit different is the endpoint here. And if the graph just goes on forever, then that's a different story. But suppose that graph ended, then these are automatically extreme points. So these are going to be local maximum too. Another local maximum here. Oh boy, it's really difficult to see anything here, right? Let's get out of this graphic mode and do an example problem. Really difficult to read like this. Let's come back to the same example. Let's identify local and absolute extrema. Oh, wrong cell, sorry about that. Sorry, wrong cell. Yeah, this is the one. So we have local maximum here, highlighted in red, and local minimum here, highlighted in red. And this happens to be also absolute minimum. That's the lowest y-coordinate. Everybody can clearly see that. This one, no, not really. It's a local maximum, yes, but not absolute maximum, because this way it's going on forever toward infinity. So here we go. Attains a local maximum at x equal to 3, and local maximum value is this y-coordinate value 3. Attains local minimum at x equal to -3, and the local minimum value is -2. Sorry about the typo. Should be only one I. And finally, f has absolute minimum at x equal to -3 with absolute minimum value of -2, the y-coordinate. But there's no absolute maximum. It goes on forever toward infinity, and infinity is not a real number. So whenever you have something infinity, then it's same as not existing within the realm of real number system. And there are more graphs, and then you can repeat the exercises. One final comment, asymptote. We have a horizontal asymptote going here, going to y equal to 0. Everybody can see that. And for horizontal asymptotes, sometimes they cross, sometimes they actually merge. It's okay either way. For vertical asymptote, you cannot actually touch, you cannot cross. Just follow, getting closer and closer, but without actually touching. But for horizontal, various things can happen. In this case, it's unclear whether it is staying above the x-axis, just getting closer, or actually merging. With this graph, it's impossible to tell, but it doesn't matter. They're all asymptote. They're all horizontal asymptotes.